Hey, welcome back to Big Data Brews. Today with Kelly. Kelly, do you want to introduce yourself? What do you do? Where you come from?
So I'm living in New York right now and am a senior engineer here at Datameer.
A kick-ass senior engineer.
Oh, some days are better than others.
What days are better?
When you actually win.
Over the bugs?
Yes.
Okay.
Always.
So tell us a little bit, what's your background and what are you working on?
My background has been a lot of, I guess, a mix of both consulting and product development. Before Datameer, I was working at EMI Music in a kind of like a skunkworks group, building newer technology or using newer technologies to solve some of their business problems.
So EMI Music is not really known as technology company. What are they usually known for? What's their biggest product?
Contracts.
Yeah, contracts?
Yeah, music contracts.
Like, for example, I don't even know EMI Music.
Really?
Yeah.
Like the Beatles?
The Beatles. Oh, okay.
Yeah, kind of. Yeah.
Oh, so you worked for the Beatles.
Well, no.
Okay, but with the Beatles.
Yeah, kind of.
Somehow. So what did you do? What did you do in that group?
So they were trying to change how internally a lot of the software is developed in the company and try to work with more of the large amount of the data that they could be using to figure out, how to sell music better, or who to advertise to, or where they should be providing, different services for the musicians or things like that. So a lot of it started out going through their, a lot of their IT systems and seeing what they were currently doing. And then we started working on kind of targeted internal products and projects.
And what was the coolest project from maybe a technology and kind of from the ID perspective?
Once we started collecting a lot of social networking data, a lot of their marketing spend, and collecting their entity data, how they structured their products, so records or digital downloads of some sort, those sorts of things from the internal systems. Once you started mixing that data together, they were able to do some pretty interesting things. So one of the cooler products was basically not a self-service analytics system, but kind of self-service. So what was pre-packaged for them, they could go access based off of data that we've collected from those different systems.
So you talked about mixing. What's about the mix here?
Well, somebody got me here because I did them a favor, and so they went and bought me some beer. So I figured I would share.
Oh, so you re-gift the beer, so to say.
Yeah.
Okay. Well, okay, fair enough. But what do we have? What's that? Beer with natural flavors added.
Yeah, so
you
it doesn't...
Yeah, you wouldn't call that beer in Germany.
This is not German beer.
No. But what's your favorite beer then? Do you even drink beer in New York? Isn't there all fancy cocktails in New York?
No, I've been switching more over to beer.
Yeah.
Cocktails get a little too expensive in New York.
Okay, so what's your...
I think one of my favorite beers is actually Green Flash. It's out of San Diego. It's a very good kind of floral hoppy IPA, which you wouldn't like either. So
no. Okay. So, well, let's open this.
You want to open these?
See
if I can do this without cutting myself?
Yeah.
Oh, you gotta be kidding me.
You must be an engineer.
I know, right? Can never do this. There we go. There you go.
Thank you. You sure it's not a twist?
Yeah, exactly.
Yeah, cheers.
Oops. Prost.
Prost. It's actually not too bad.
Yeah?
Refreshing, yeah.
Yeah. Good workday beer.
Yeah. Kelly, tell me a little bit about that activity feed that you guys built it based on Hadoop. I mean, that's maybe 5 years ago, but that was a cool idea. How did you guys overcome, and what was the challenges you tried to solve in the beginning?
So initially we started out, working, knowing that we were going to start basically drinking from the fire hose of the data. So we started out working with Hadoop to build out, even though the data sizing didn't really require it. We knew once we started collecting a lot more of this data that it was going to get into larger and larger data sets. So we wanted to be able to scale quickly for that need. So the idea was, since we were running on AWS, that we could just store a lot of the results of that processing in S3. So that way, even like JavaScript-based apps could just go and fetch from S3.
So you basically pre-processed, stored the results in AWS, and then you didn't have to do any database queries, or?
Exactly.
Yeah, okay. But everybody would say, oh my God, why would you store all this, and isn't that expensive?
Yeah, but if you already know the queries the users are going to execute, then it's easy enough to basically pre-generate all of them and just store them in S3.
Right.
And then the cost of adding a database layer and querying and everything else, it didn't really solve the underlying problem, which is like we were basically doing report generation, and since we had Hadoop there, we could just generate all the reports at once.
Yeah.
And
I guess it's against the gut feeling of a normal engineer, but in the end, economically, it makes a lot of sense, right? Storage is incredibly cheap.
Yes.
The user perceives that it's super fast because it's pre-processed.
Yep.
Oh, interesting. Okay.
So, I mean, some of the technology wasn't quite there at the time, working with JavaScript and the front end and fetching the stuff from S3 wasn't always that easy. But then, so in other places, we would just, stand up a MySQL to do it. Especially where we needed to do simple queries on the data, like simple filters and things. But again, even in that case, we just used the Hadoop job to feed into MySQL.
Nice.
So
you definitely, EMI was one of the very early Hadoop users that did quite sophisticated stuff there.
Yeah.
So what are you working on today on what's kind of the exciting projects you're working on today from a technology perspective?
So I've been getting into our visual analytics, so the more the kind of like data mining like algorithms that we have in the product, helping to make those very fast and performant and hopefully usable in the product. And most of the time I spend going through our the backend code base, especially our integrations into Hadoop, and working on how we process data in the workbooks and on the import jobs. So
what do you like and what do you absolutely not like about Hadoop as you like work with the beast on a daily basis?
It's gotten a lot better.
Oh, that's good.
Yeah.
That's good. Well, cheers on that.
Yeah,
let's swing on that.
Yeah.
Okay.
Thanks to all the people at Yahoo and Hortonworks and Cloudera for making it a lot better, for sure.
And MapArm and IBM and Oracle and Microsoft and NetApp and all of you, thank you.
Yes. And whoever we forget. Yeah.
Sponsor now.
So, when we first started, especially even back at EMI, like, things would change, a lot of API changes like rather rapidly, and worst cases, semantic changes. So even though the API didn't change, like semantically it worked different, which are harder to deal with. And here at Datameer, can be much bigger challenge because we want to support, all these different distributions and things. So, but as I've said, it's gotten a lot better. Some of the initial, issues, even like HDFS not having a good bulk interface, when you are dealing with lots of files, like that's been addressed in 2.0 now. And same with, I just checked out, but we've had issues before with like class loading because we use a lot of jars and stuff, that libraries that, make our jobs easier, but also Hadoop communities using them, and sometimes they use an older version, and then, you always run into problem. Yeah.
What are the new features in 2.0 you're most excited about?
I'm most excited about? I'm actually really excited that they're starting to publish, what APIs are more fixed, what is really published versus just public for, easier coding on their side, things like that. Yarn is definitely very interesting, and I think especially for what we do here, there's going to be a lot of cool stuff we can do with it, and especially building some of our analytics and stuff on top of that, I think would be a very big win.
Yeah, but you didn't answer my question around what do you really hate about Hadoop. For a guy from New York, you seem to be very polite. So, I mean, go for it.
Yeah, I think initially there was a lot of, especially using that programming model for even like smaller amounts of data just to get some simple parallelism.
Yeah.
Like a kind of like a nice sandbox that MapReduce gives you. That was always kind of never really, it wasn't really dealt with very well by the core.
Yeah, they always thought of 2,000 machines, right? They never thought that there might be normal people that just have a couple 3 machines, or maybe just a single multi-core CPU machine. Yeah,
and certain things I think that would actually make MapReduce still like faster and relevant. Like some of the things that they want to do for like in Hive with like Stinger, like there's been certain papers from Google that have shown that like even removing the sort from like the MapReduce, the shuffle, in some cases can give you really good speed, and that's one thing that's been kind of like they don't really want to fix it. Yeah, which to me is like one of those, for us it would be pretty useful. I'm sure for a lot of people, other projects like Pig and Hive would also find it very useful as well.
In all that work you did in Hadoop in 6-7 years now, like what are the I know you like a research paper guy, you always have the latest and you send stuff around. Like what's the most coolest publications around that that you might want to see in Hadoop or that you run over?
Okay.
What's the latest one? Or
as I said, that the Google paper where they built the SQL engine on top of MapReduce and did some of those optimizations, I think that would be very useful to see in Hadoop.
But are you a fan on SQL or Hadoop? I mean, I'm the wrong company for that.
It's a tool, and if you can model your problem like that, and it's faster for you to do it that way, I think it's fine. I think a lot of the power that we have in some of our, especially in the way our aggregation system works and the series calculations and things, I think there's way more you can do outside of SQL, because SQL being set based.
Good job.
Yeah. For me, I try to be very pragmatic about it and know that some people they think in it, but sometimes it's easier to solve a problem a different way.
So outside of your Hadoop, any technologies you're really excited about? You talked a little bit about the interactive visualization you do. So are you involved with D3, or are you excited about any other cool stuff in the back end? Like, what's your hobby? What's your technology hobby, or like the thing that excites you?
The thing that excites me is, I guess, working with like distributed systems and like kind of language support for that. So I've been looking at Go as a language, and I think technology-wise, there's a lot of great stuff in there.
So tell us more about this. Go.
Go. Well, I mean,
that's coming out of Google, right?
Yeah, and so basically they're kind of marketing it as a replacement for other system languages like C and C++. And it has a lot of great ideas in it, and it's very simple. And one of my favorite things about it is how quick the compiler is.
Like, what cool ideas do they have? I mean, they have
the
inversion of control, for example.
No, but the biggest thing is it's kind of like inversion of control. Is Go routines and channels for communication between them. So instead of doing concurrency with locks and threads and stuff, you actually
it's more kind of an Ector model, maybe.
It's similar. Yeah.
Okay.
It's a lot of it's based off of Tony Hoare's paper on CSP, communicating sequential processes. So that influenced Rob Pike, I think, for a long time, and so that's why that's in Go. And based on some of the stuff that I've had to build even for Datameer, like when we are dealing with something as simple as, like, let's say parsing values out of a file, we never know. It's like, well, are you going to give us more than one value out of that or not? And that is really easy to describe in Go, where in Java you have to spin up a thread or work on a buffer. Or
is it more event-based? I mean, I've never worked with Go.
It's not really event-based. It's more, as I said, like you can spawn up a lot of little mini processes that manage that kind of that stack for you. So in Java, where you end up having to kind of create a state machine to do these things efficiently, in Go, you
like
can
it's Java CC drum or some fun thing.
But in Go, you can just say like, I'm going to send something on a channel to the next thing, and it'll pause.
Oh, I see.
You have it pause and wait at that point, or if it's buffered, it'll keep on going. So you can do a lot of it. I guess for me, what it does is it's like the language is helping solve a lot of those common cases that I run into a lot.
How's the syntax look? Do you want to write a little hello world on that? No, why not? Hello world and Go.
No,
I guess it's just Go.
I'm not a good whiteboard programmer. Let's put it that way.
That's a special skill set.
Yeah, I think so.
Okay, Go. Let's switch topics. Good engineering books.
Engineering books?
Yeah, well, like, books you read. I mean, you're just such a effort. Right? Yeah. Blogs, I guess. Blogs. I mean, what should I read?
What are you trying to do?
Well, I mean, you sharing always really cool content. So, what are the things that are maybe interested in big data or good sources to follow?
I think the last book that I really liked that I just quickly ran through was when I was coming up to speed with a lot of the stuff that we were doing with the more, the data mining algorithms was, I think it's a little older, but it was Programming Collective Intelligence. It's an O'Reilly book. And from a high level, and the Python code's pretty easy to read. It gives you a good idea of what these algorithms are good at, what they're not good at. And the thing I really liked about it was it had great examples of using both kind of generated data. So what's the best case, but then also then where to go find other data from web services, then you could build stuff out of this. So, or use those, use that data from the web service to then apply those algorithms to see how well or not it's finding, either it's classifying something or building clusters or whatever. So
cool.
But yeah, from most of the knowledge I guess I glean now from most of the books I kind of stay away from. It's a lot of it just searching the internet and finding stuff. Yeah.
Okay. So you very well known in the company for having really awesome node shorts. I have to bring this up, but where's the secret?
I mean,
what's the secret sauce to get really cool engineering shorts?
Engineering shirts? That's different. I mean, most of mine are pretty nerdy, I would say, more than engineering. Yeah.
Okay.
Lots of video games. I think being a child of the 80s and having a Nintendo, and that was, so anything associated with that was usually where I would go. Uniqlo, which is the kind of Japanese Gap. They usually have really great t-shirts, prints of different things. I've had some good jazz album covers and a lot of video game shirts from them. Also, the t-shirt Woot has got some good stuff on it. Yeah.
So the most WTF emails I get in this company are actually from you. So anything specific, that maybe in the market and the technology that you really scratch your head, why the hell would that happen?
Yeah, I think the focus on speed kind of bothers me sometimes. Yeah. That it's always, how quick can I get this? And
is it query speed or time to insight? What do you mean with speed?
Well, I think it ends up being query speed.
Yeah, right? My Hadoop is faster than yours.
Yeah, and it's can you actually react in that time? Or it's maybe you just don't know, if you're doing ad hoc queries and things, sometimes you maybe want that to come back quickly so you know where to go to next. So you're not waiting an hour or 2 hours or whatever, which I guess I can understand some of that. But, if, as I said before, we were even doing batch stuff at EDMI and other places, if you know what you have to solve, you can just solve it in a more general sense and just, run it end versions of it and build way more reports, why
parallelism,
use parallelism instead. And I think it's great that people are working on these technologies, but I think if people are just starting out with these technologies, it's, I think, kind of the wrong thing to look at.
It's like the best distributed system is a non-distributed system.
Yeah.
Right. The refactoring guy, what's his name?
I have terrible names too, but I know what you're talking about. Yeah.
Refactoring.
That's a good book too, by the way.
Yeah. Do you like Java puzzles?
Yeah, kind of.
Yeah.
But I don't like finding them in the code base. That's usually where I find them.
No. So, what's important from in an engineering team for you? I mean, you're super senior. How do you make building a complex product like Datameer work? What's the kind of big teams, small teams, Waterflow, Agile? What's your
I think everything should be done with Waterflow.
Yeah?
Yeah, perfectly designed out the first time.
Okay. Yeah. Like UML diagrams and you press generate code?
It just works the first time.
I know. I was there. Poseidon UML, 90, 98 maybe.
Yeah. No. So I do like small teams. I like kind of like small, good, strong teams together, where each person has a strength, but still kind of a generalist. So you're not, you don't have to deal with like bandwidth issues or whatever. Like, oh, this is the only person that knows how this works, right? Like everybody should own it. And I think, obviously, the testing stuff's kind of important and all that fun stuff. But I also think about, the solving the real problem and not, either scratching some technology itch or things like that.
Yeah. Well, it's a common problem, especially in the big data space, where people just scratching the technology itch. Yeah.
Yeah. And also, willingness to fail.
Yeah. Okay.
And being very vocal about it. I think it's very important. I think a lot of times, as engineers, we try to be very smart and smarter than the next person. Like you're in some meeting with somebody, like you feel like you maybe have to like show them how smart you are.
This really needs to be in memory, real-time analytics on distributed something.
I know all the latest and greatest. And I think if you can kind of step back from that and be like, oh, that didn't work, that failed, and the team is very vocal about that, and then learning from that, right? Obviously not failing every time and then like doing the same thing over and over again, but like actually having real feedback.
Do you feel that things like Git help to nurture those kind of new processes?
I think
or like which tools help to move in that right direction?
So I don't know if
or is it more a social problem?
Yes.
Okay.
Yeah, I think it's more of a social problem because the tools can either help you or hurt you, depending on your understanding of them or whatever. I mean, I think once you learn how to use things like Git or Mercurial, it's like, a night and day, right? Because you're like...
Compared to CVS.
Yeah, because like the whole failure thing, I'd be like, oh, I broke this. Well, okay, go back in time. It's fine. Right? It's not a big deal. The decisions you make, especially in a large code base, it's very easy to be like, to have a little, oh, I'm going to experiment with this. Yeah. Let's see if this works. Yeah. And then come back and be like, okay, it didn't. So now what? Okay, let's go down this path, right? Yeah. Like the tools enable you to do that, but if the culture's not there to have that feedback and to accept the fact that you're going to make mistakes, you're going to create bugs, you're not going to just fix them. You without that, I think it's a lot harder. So for me, like being very vocal about it.
So in context of teams, Frank, our VP of product, has this theory, right? And I want to see how that resonates with you. He says a perfect team is 4 people, not 4 people, but basically 4 characters. One character that is an innovator, one character that question things, right, to the innovator, one character that just gets, excuse my German, make a beep, shit done.
Yeah.
And then there's one guy that tries to kind of non-refactor, just, never touch the working stuff. Kind of the guy or the character that tries to maintain existing stuff. So what kind of characters do you see in that perfect team that you described? Like generalist with some focuses areas or?
Yeah, I mean, I would hope that some people kind of wear those hats.
Like
in the team.
Yeah.
I'll make a distributed programming joke that, you'd probably be 5, so you have a quorum.
Okay.
So it's not 2 against 2, because then you'll never get anything done.
Yeah.
But yeah, I could kind of see that actually.
Yeah.
Yeah, I see that in our team. You
So,
know,
but it needs to be 5 to get a quorum.
yeah, that's what I'm saying, right? So you have to have at least 5. So there's probably maybe 2 get-her-doners or whatever.
Yeah.
So,
anything you want to give away or advice for big data folks working in the space? Like, never touch that API or
keep it simple.
keep it simple.
Yeah, I think a lot of people have a tendency to kind of run to the latest technology and just to use it, even though maybe there's a better way to solve their current problem. Because the more things you add to the system, the more complex it gets, and the more you then have to deal with those complexities. And it's funny because like we talk about this, what we did at EMI, and it was like, well, we're using Hadoop for things that maybe it wasn't quite, at the time, initially it wasn't necessary for, which is adding some complexity. But what we were able to do rather quickly with it by building a simple like data warehouse system on top of S3 with it, by just using it like files, what most developers are used to. If you like know Unix or know any of that stuff, it's you can start there. You don't have to go directly into some of the other more interesting technologies that run on top of it. And I think quicker you can solve the real problems, then you can you'll get more and more interesting problems to solve. Then eventually you can start adding those other.
Well, then over engineering.
Yeah.
Good. And is there a Go binding for MapReduce or something like cascading?
I don't know. Actually, I haven't looked at it.
You didn't try?
Well, it's one of those things where it's like that's what I do for my job, right? So sometimes it's like nice to not have to think about it for that, right? You can be like, oh, I'm going to code something else.
Yeah, cool. Hey, thank you very much, Kelly, stopping by from New York. Enjoy the wonderful winter. Good luck with that. And come visit in California if you get cold feet.
Anytime.
Cheers.
Thanks.